All right, folks, back in the shop, working on the Cub Cadet 4x4 articulating tractor slash dump truck. Got a couple things to wrap up with the lifting frame, which we started on last week. Provides the support for the hydraulics to lift up the bed, so it needs some kind of a frame to support that. We started on that, did most of that last week. Got a couple of loose ends to tie up on that. Then we're going to get into what I think might be a surprise for some of you, and probably maybe not a surprise for others. I'll let you figure that out when I start working on it. Want to place the hydraulic cylinders, and I'll talk to you about, show you what I've run into with that. Interesting. I think I got a good solution. I don't know that I can complete it all in this episode because I've had to order some more parts, but we'll get there. All right, stick around. You see what I'm talking about. I'm going to weld a plate on here, of course, to connect these 2 points together to stiffen that up. So that's yet to be done. All right, let me go drill some holes for cotter pins. Inch and a quarter. All right, so that keeps it from moving back and forth. All right, I've got this piece of bar stock between the two lift frame pivot brackets, and this will strengthen the frame here. It's probably overkill, but never hurts. All right, so I'm just going to tack this in place right now. All right, so you see, I tacked it in the wrong place originally, so I'm fixing that mistake. All right. Of course, you know, all this tacking together is in anticipation of, you know, having to make another change potentially as I work through the geometry of the lift cylinder. I think it's going to be fine. I have to come back and spend some time, you know, completing all of these welds. So that's expected. What you guys doing? Huh? What you guys doing, huh? Being good boys? You being Daddy's good boy? Huh? Okay. Something going on outside you want me to know about? Is there something going on outside you want me to know about? I don't think so. Otherwise, I'd have heard some barking. All right, if you haven't figured out yet what I'm doing, No, that's too high. Here, there you go. Okay, as you may have surmised, I'm going to drill through the frame. I'm going to move the axle back. Now, this is my mag drill. Normally you use annular cutters in it. The problem with that is I've got to drill through two layers of material, the 11 gauge or 1/8 inch original frame, and then the 1/4 inch frame stiffener plate, which is inside it. The problem with that and using annular cutters is they cut out a plug, and then it sits there. After you've drilled through the first plate, that plug keeps you from drilling through the second plate because it blocks the cutter bits. So this is a Jacob's chuck, which comes with this drill. This is an Evolution brand. It's been a good drill. I mean, I haven't had any issues with it, but we'll see. All right, now I need to get a 1/2 inch drill bit in here. Make sure I have, the space for one. I think there's quite a bit of adjustment on this, so should be able to get a 1/2 inch drill. So let me get a 1/2 inch drill in here. All right, so I've got a drill bit here. It's actually a 31/64, so it's nice, sharp. I don't know if it's ever been used, but it'll make the drilling easier. I'm using 3/8 inch bolts. That's what the transmission differential requires. So I've got to drill 3 holes on each side of the frame, and this will make it a lot easier to do than doing it by hand. All right, that gives me clearance. I need to trim, you know, this frame folds under on the bottom, and I can't have that fold there where the axle bolts, so I've got to trim it off. Oh, there's my Butchie. How you doing, Butchie? Oh, and of course, Brew Brew's not far behind. These guys are inseparable. They've been together since birth. They're brothers. They go everywhere. They're like, one's like the shadow of the other. All right, little pause here. Recap. Cut the flanges off the bottom of the original frame. This allows me to slide the transmission back. I'm going to move the transmission back 7 or 8 inches. I think I measured 7 inches. It's about all I can do without the hydraulic filter sticking out the back. So I think that'll put the axle maybe not centered under the bed, but pretty close to it, within a couple inches. So I think it'll make it look a lot better. I think there were several comments on the channel about if I wasn't going to add a third axle, at least I need to move the single axle back. And of course that was always a consideration, and you know, I think it's come, you know, time to do that. Once I got the wooden mock-up of the bed, you know, it became apparent that it would look better with the axle further back. Now the compromise of that is now the pivot point, and we talked about this very early on in this build, the pivot point was equidistant between the two axles. And there was quite a controversy in the comment section about whether that was necessary or not. And it may be better for it to be that way, but it will certainly work with the axle an extra few inches behind the point of center. So that's what's going to happen here. All right, I've got, as you can see, the rear of the frame jacked up with the forklift, and I'm going to go ahead and drill some holes in the frame. I got them marked, and we'll lower it back down on the transmission, which is sitting on this dolly, and bolt it back up. The only really change necessary to permit this, and the reason I'm doing this, you know, it's not too difficult to do, is just lengthen this transmission control rod by the same distance, 7 inches. So that's all that I really have to do other than drilling the holes. And there's 3 holes per side. 2 go into the axle housing, 1, 2, and the third one bolts to the transmission back here. So, all right, we'll drill some holes. Okay, so I spent a lot of time thinking about the hydraulic cylinder placement, and originally had a larger cylinder. So there's a couple of considerations. One, you want some down angle if you can get it, which decreases the force required to lift up the bed. A couple other things, the closer this lift point is to the midpoint or whatever, the less force is required. So there's a lot of the geometry of the relationship between the push point and the lift point, I call them that, matters. The 2-inch cylinder I had is just created two problems. Two problems were created by it. One, it's pretty big in diameter. The ports on it are large, so the fittings, the hydraulic fittings for it would created an interference trying to mount it in the center. The drive shaft is here, so it created some problems. So what I've decided to do is use two smaller cylinders. I had this one already and I've ordered a second one. So I think I've got a reasonable mounting position here. I've got one here and I'm going to mount one on the other side. So I have two cylinders. They'll be plumbed in parallel. And I think I've got it sorted out so that, let me take the plug out of this other port. Hold this. I have these rods mounted on pillow block bearings or flange bearings, and I'm missing one, so I've got to just hold it over here. But either way, it does lift to nearly vertical. So I give you another point of view of this motion is to there, which I think is perhaps even further, more vertical than I need it to be, but certainly adequate. So I think I've got my cylinder locations set up. I don't have the other cylinder yet. I've ordered it. I don't know if it's going to make it in this episode. We'll see how long it takes for it to get here. I did have to lengthen the drive shaft. I've done that. It's complete. The hydrostat control has been disconnected. I need to lengthen the actuating arm here 7 inches and remount the control, the bracket here for holding it. So 2 more things to do. Let that cool off a little bit. Alright, I'm going to make a extension for the control shaft. Got to put 1/4 28 threads on both ends. We'll go ahead and turn this down to the major diameter for the 1/4 28 thread, and then thread this end and turn around, drill and tap the other end. All right, I'm at 0.253. I'm going to say that's close enough. All right, so this is my die holder. It is holds the die in here. It floats on a shaft, Morse tape or shank behind it on in my tailstock. And when I push the handle this way, a clutch inside engages, the die engages the workpiece and threads on as the workpiece turns. And when I push it the other way, if I leave it centered, it just spins. If I engage the clutch the other way, it'll unthread. I'll have to reverse the direction of the chuck, of course. So I'm going to thread this shaft. This is 1/4 28 thread. Get a little bit of oil on here. Maybe. There we go. All right, let's put that back. Let's check the thread with this nut for test fit. All right, that's perfect. If you're interested in this die holder, there's a video on my channel where I made this, so you can check that out if you're interested. I'll leave a thumbnail on the end screen. This is the drill size, 7/32.
I'm a little disappointed here.
Wake up, wake up, wake up!
About time.
Some anchor lube on there. Seems to be the best cutting lubricant for threading and tapping. I wished I had a spiral fluted tap. Would be much better for this application as it would eject the chips. This is a gun tap or a split point tap. It pushes the chips forward. Now I drilled the hole, plenty deep, and I only need about 1/2 inch of threads. And I don't feel any resistance. This is still cutting the threads quite easily. At some point I'm going to feel resistance and I'm going to have to back out. There you go, probably right there. Okay. Tailstock out of the way. So what I'm using is anchor lube, right? Of all the stuff I've used, I think I like it the best for tapping, cutting threads in general. All right, I've got a lot of crap in there. And of course, crap is a specific technical term. Now, this anchor lube is actually water soluble. Yeah, Now I have to re-oil my ways after spraying solvent. All right, so that's the part drilled and tapped there, threaded there. All right, so that's my extension. Well, I misjudged the location of these two holes here, so I'm just going to drill 2 more holes over here. Got to be closer to this edge so they fit in the location. So we'll locate them on the y-axis here. Close. Something like right there, you'll be fine. I'll come back to the same X coordinate. I'm lining up with the other hole. There. I can get it through there. Get these. All right, so this puts the flexible shaft Somebody chastised me in the comments for calling it a flexible shaft. That only applies if it spins, is what he was saying. It's a flexible rod. Yeah, I'm gonna wind up having to resync my hydrostats after doing this, but that's okay. Kind of expected. All right, so here's my extension. 7 inches. It's actually 7.5 to make up for the 1/2 inch of thread engagement here that lose in the process. It'll be interesting to see how far out of sync it winds up being. So that's about all I can do till I get the other flange bearings. They seem to be the easiest way to make these connection points removable for service. So we'll come back. All right, folks, that's about all I can get done without the additional cylinder and the flange bearings, but this is a good stopping point. I'm stoked that I found a reasonable position for the cylinders. After I moved the axle back, it kind of changed my plans, and so I struggled a little bit trying to fit one cylinder in there, but it's just not going to work. So the 2 cylinders solves the problem, and we'll come back next week finishing up the cylinder install, perhaps get some hydraulic lines run. Not sure how far we'll get, and then after that we'll start building the bed. I do want to get the lift frame working before I think I want to get the lift frame working before I build the dump body, in case there's some issue that forces me to build the dump body differently. I don't know what it would be, but there's always that potential. So that's where we're headed. Thanks for watching, and we'll see you next week.